Hi everyone, today I'm going to talk about how to properly connect the wirings of your brushless motor for the HAL sensor and the motor to solo to be able to do a closed loop control with HAL sensors in a speed or torque mode. So to do that we have to divide this tutorial into two phases. The first phase is connection of the HAL sensors wires to solo. And the second phase is connection of the motor wires to solo. The first phase is pretty easy. What we have to do is this. The assumption in this tutorial is we have no idea about the wirings of the motor and the wirings of the HAL sensor. The only thing you need to know is from these 5 wires that's coming out of the HAL sensor part of the motor, which one is the supply wires. So there are 2 wires for the supplying, GND and plus 5 volt normally most of the brushless motors, and we need to know them. So I know those 2 wires. The other 3 wires which are for HAL sensor, I have no idea about them. I don't know their order and I'm gonna find it out now. So this is the first phase of this tutorial. In my case, I've connected my motor based on an arbitrary connection to my HAL sensor, and I'm gonna see what happens when I connect it to solo. So I only know which pin of my motor's HAL sensor is for 5 volt and which pin is for ground. I have no idea about the wirings of the HAL sensor. This is an assumption. So I'm gonna put the HAL sensor in the place in this connector that is provided on Solo Uno, and then I'm gonna verify if the order of the wirings of the HAL sensor is correct or not. So let's do that. I put the connector in place and I don't connect the motor. I don't need to connect the motor. I just need to turn on solo and verify the rate. So I turn on solo and I see it is blinking, so that's a good sign. Now I need to go to the motion terminal, open the motion terminal and see what I see there. So I go to the motion terminal, I get connected to solo, and this is actually the default setting right after the reset factory that you see. So I haven't done anything up to now. I just opened the motion terminal. This is the default view. So what I have to do, there are steps of things that I have to do, but the very first thing I have to do is I need to make sure the current limit for this motor is actually the current limit that the motor can sustain. So it's actually the maximum current that this motor can sustain. In my case, this current limit is 10 amps, so I put it 10 amps, I press enter, it sets it. The next thing is this, you need to make sure the number of poles of your motor is actually correct. So in this case, my motor has 8 poles, and which is fine, and I put 8, so it's not a problem here. I don't need to change anything else. I just need to go down and put this speed control mode, or actually the mode of finding the angle, on using HAL sensors. So once I do that, I would be ready to see the combination of the HAL sensors if it's correct or not. So for doing that, I'm gonna go to performance mode monitoring. Here in performance monitoring panel, I'm just gonna deactivate everything I don't need, including the position, the currents, and the speed. I just need to see the angle. So I activate the angle and I activate the monitoring mode. So I see there is a plot going forward. I zoom a little bit and probably it's nice. So now I'm able to see if the motor, the connection of the wirings of the HAL sensors of my motor is properly done to solo. There are 6 combinations that you can connect the HAL sensors A, B, C outputs to solo A, B, C inputs of the HAL sensors. Out of those 6 combinations, only 3 combinations will be fine according to this tutorial. So let's see that. In order to see the correctness of the angle, I need to turn the shaft of the motor while it's facing me into counterclockwise direction first. So I turn the motor in counterclockwise direction, and this is what I see. I see some sort of sawtooth shaped plots that the shape is kind of like this. It starts from a minimum value, it ramps up, it reaches to a maximum value, and it drops down. This is actually a correct shape that I have to see while I turn the motor in counterclockwise direction. So let's see what happens if I turn the motor in clockwise direction. So if I turn the motor in clockwise direction, I see actually something totally reverse of that. So what I see is this. I see now the plots are starting from a minimum value, just jumping up and then ramping down from that value which is completely different with the other shape we saw. Basically, what you have to see is this. When you turn the motor counterclockwise, you see these kind of shapes, and clockwise, these kind of shape. So, like that, I stop. So from here, I can guess that, okay, this was the counterclockwise, this section, and this section was clockwise direction. And this shows me that the connection of the HALL sensors are actually okay. If you connect the HALL sensors wrongly, the order is not correct, you will see the reverse of this. So when you turn the motor counterclockwise, you will see that a shape like this one, which is not correct, and you have to swap the wirings of the HALL sensors connection to solo until you reach something like that. So counterclockwise like this and clockwise like that. The beauty of the shapes of these angles is not important because we are doing this by hand. Once you run the motor, they will be very beautiful and nice, but for now, this is a good way to start. So like this, I made sure that the connection of the wiring of the HALL sensor is correct. I repeat that out of 6 combinations you have here, 3 combinations will result in the same thing that we saw here together. The next phase will start. The next phase is connection of the motor's wires to solo, and see in which combination the motor actually works well. So the combination of the HALL sensor remains fixed from now on. The only thing we will need to change is the connection of the motor. So let's do the second phase and find out what is the best connection. Now I'm going to find the wirings of the motor. What I have to do before doing anything, I need to turn off solo. And I have the wirings of the motor like this here. And I'm going to find the proper combination of these wires with respect to these wires. So the HALL sensor wires are fixed. I'm not going to change them at all after now. The only thing I can change is the wirings of the motors, the order of the wirings to the A, B, C of solo. So we have the red color, black color, and yellow color here for the motor's wires, and I'm going to find the best wiring for that. So to do that, I need to start from somewhere. There is only 6 combinations that you can try. I'm going to make my lookup table, and I'm going to start with this. I'm going to connect firstly an arbitrary connection to this A, B, and C. I have no idea about these wires. I just want to connect them in an arbitrary manner and see what happens. So I will start with this combination. I will connect the yellow to A. Okay. Close the wires. I connect black to B. Close it. And I connect red to C. And close it. So now I have one combination connected. I have no idea about this combination, if it's okay or not. I'm going to find it out. To do that, I turn on solo. So now you have to do 2 things. First, you need to make sure the motor type is properly selected on the piano switch. So my motor type is a normal brushless motor. So I just put the pin number 1 of the piano switch down to select that. And then you need to put solo into closed loop. To do that, you need to press the pin number 5 also down. And after pressing that, you're gonna see that the motor will be identified. This is actually happening while you are pressing the pin number 5 down. Pin number 5 must be down because the calibration and everything we do from now on is done in closed loop. So pin number 5 always has to stay down. So now I'm going to go to motion terminal. I'm going to get connected to solo. And I'm going to read all the values. So these are the values. The current limit that I set before. The number of poles is correct. The PWM switch frequency for this motor 20 kHz is fine. Now what I need to do is this. First, just to make sure everything is correct, I need to make sure the motor type is properly selected. So I just send it to make sure everything is fine. I read it. The motor type also in digital mode is selected on normal brushless motor. I redo again the motor identification just to make sure everything is identified, and these are my values. Now I will do this. While I have the motor in my hand and the current limit is set, I'm going to run the HALL calibration, HALL sensor calibration. Remember that HALL sensor calibration is done in full torque mode, and the full torque mode means it's done with the maximum current that you put here. It's a maximum current that probably it will be used during the HALL sensor calibration. Maybe it's not used, but the best way is always to put this current, the maximum current that the motor can drain. So we do the full torque Hall sensor calibration. If there is any load or anything on the shaft of your motor, this is important. So to do that, I'm gonna just press the Hall sensor calibration, and during the Hall sensor calibration, the first tip is this. If the connection of the motor's wiring to solar is correct, during the Hall sensor calibration, the motor should turn clockwise. If it turns counterclockwise, it means the motor's wiring is not correct and you can immediately discard the motor wires. So let's see what happens now. I press the Hall sensor calibration. I see that there is a current drain from my power supply, it's like 1 amps, and the motor is moving in clockwise direction, which is okay, which is the first indication that the wiring of the motor is probably correct, but I'm not 100% sure. This is just an assumption. This is the first assumption. So I read all the parameters. You see that after running the Hall sensor calibration, I have 2 values appearing here in the offset of the encoder and Hall, that those are actually identical values. Now, the next step, after you see that the motor is correctly turning in clockwise direction, so we've passed the first test, is to test that if the motor is actually working well in the torque mode. The torque loop is the first loop that comes to control the motor, so if the wirings of the Hall sensor and the motor is correct, the torque loop should work. So if you immediately after pressing the Hall sensor calibration go up and read all the parameters, you're gonna witness that you will be in command mode in digital torque mode. If you're not, you need to go to digital and you need to go to torque mode. So, and you see that the control mode is on Hall sensors. Now, to see if the motor works, if the connection of the wiring of the motor's wires and the Hall sensor is correct, if I give a reference for the torque, I'm expecting the motor to rise up to its nominal speed. So I'm gonna put a 2 amps current and I see, okay, the motor is turning very well. So the motor is turning. I can also see here what's happening. I'm gonna go to the speed and I'm gonna also see the torque. So this means that if I stop the motor and do it again, send again see that the motor speed rose to its nominal speed, which is 3000 RPM, and there is a torque. So this is the first indication that probably this wiring is correct. Now, what I have to do is I have to change the direction and see if it works. It works perfect. So this means the torque is correct. Now, I need to check the other loop, which is the speed loop. So I'm gonna go to the speed loop and I'm in digital mode, so I need to set the gains for the speed controller KP and speed controller KI. I'm gonna put 2 gains that I know what are these, because the goal of this tutorial is not finding and tuning the speed controller, but I'm just gonna test the speed controller. This is the last step and this is the definitive step that the wiring is correct. So I'm gonna test it now. I put 1000 RPM for the speed and I'm gonna see if the motor reaches to that. Yes, it's actually following the reference. So you see that the motor speed is now on 1000 RPM, and if I change the direction, you see that the motor changes the direction and the speed again is 1000 RPM. So this is perfect. This shows to me that the wiring of the motor and the Hall sensors are matching. So this is a wiring that I can use all the time. Even if you change this motor to another motor from the same type, from the same value, to thousands of these motors, as long as the motor is the same and the wirings are identical to each other, you can use exactly the same values for the calibration values and also the wirings connection to solar. Now let's see other wirings of the motor and what happens if a wiring of the motor is not correct. To do that, I have to stop the motor. So I stop the motor, put it down, I turn off solo. According to my table, I go to the next combination of the wiring. This is just out of curiosity. You want to see what happens if you change the wiring wrongly. So what I will do is this. I will keep the central wire constant and I only change and swap the wires from A to C all the time. This is faster way to find the wirings. So now I have red, black, yellow. And let's see if I can repeat everything again or what will happen if I do that. I turn on solo, never change the wirings while solo is on. So always turn it off. I turn on solo, I take the motor, I go to my motion terminal, I get connected again, read all the parameters. I need to repeat the Hall sensor calibration. So I'm gonna press that and see what happens. In this case, you see that the motor is turning in counterclockwise direction. This is not good. This is the indication that, okay, we can discard this immediately. And even if I read the HALL sensors calibration, you see that they have changed to these values, but the motor didn't move in the correct direction. So I can immediately discard this connection. I put it in my table and I discard it. So I go to the next combination, turn it off. So now I turn on solo and I'm gonna repeat again the process. So I go to the motion terminal, I get connected, read all the parameters. So I just run the HALL calibration. Let's see what happens. This time it should turn in clockwise direction if it's the correct way. So yeah. So the first phase is passed. This doesn't mean that the motor's wires connection is correct. It's just rotating in a correct way. So it means that probably this combination of the wires is okay, but we have to do other tests. So after the calibration is done, if I read the parameters, I see that this offset for counterclockwise direction is 0.4. It's changed. So it's a good sign that, okay, the calibration went fine. And you saw that the motor turned almost like one turn. And now I'm in digital mode, torque mode, like the first time. I'm gonna see if the motor turns with 2 amps of the current as a reference. It's turning, so this is good. It means that it's turning in clockwise direction and probably the motor is reaching to its nominal speed. Let's repeat this again while I'm here. The monitoring is going on. If I give 2 amps again, you're gonna see that the motor accelerates slowly to its maximum speed, the nominal speed of 3000 RPM. This is the first sign that probably is correct. Now I need to change the direction. I let it go to the monitoring. I change the direction to counterclockwise and I see, okay, the motor changed the direction. Also, I can see here. So let's repeat again. I go to clockwise. I see this happen and I go to counterclockwise and I see the motor is changing the direction. So that's fine. That's the first sign that probably everything is okay. To make sure, also in a speed mode, we have a correct combination. I go to the speed mode. The gains can remain the same, the gains that I set previously. I just give 1000 RPM and I'm gonna see what happens. Yes, the motor is moving with 1000 RPM very nicely. It's following the reference. It's actually 1000 RPM. I stop the motor and I run again just to see better the shape. So you see that the gains are not perfect, so this is why it's going slowly up. So this is another combination that the motor actually is working in that. So with this HALL sensor connection, till now we found 2 combinations that the motor is working with. So now I'm gonna go to the next combination. I turn off solo. The next combination is this. I need to keep the central wire fixed and I just swap the A and C. So let's see what happens there. Probably the motor will turn in counterclockwise direction during the HALL calibration, and that's a sign that the motor is not well connected. Okay, I turn on solo. I get connected to the motion terminal again. And okay, I read all the parameters. The parameters should be the same as before. Now I just need to run the HALL sensors calibration. I run it again. You see that the motor is turning in counterclockwise direction. This is not a good sign. This is the sign that the wirings of the motor actually, it's not correct. So I don't need to go to the next phase. I just can discard this wiring and go to the next combination. The next combination is the 5th combination. So now the combination is ready. I repeat again everything. I just turn on solo. E2 is blinking. The motor is here. I go to the motion terminal. Read all the parameters. Everything's perfect. Now let's see if the motor turns in clockwise direction. Okay, perfect. So this means probably this wire connection, this combination of wirings to solo from the motor is correct. Who knows? It turned in clockwise direction during calibration, which is fine. I read all the parameters. I see that, okay, there are 2 new values for especially the counterclockwise offset, which is because in the HALL sensors calibration, only counterclockwise offset matters. The other one is not important. So now I'm in digital torque mode, like the old times. I'm gonna put 2 amps and see what happens. The motor actually moves well, turns well. I change the direction, it's okay. So the first loop is perfect. The second loop, which is the speed loop, now I'm gonna see if I can go to 1000 RPM. I can, perfect. So if I change the direction just to see if it works, okay, it looks it's working, perfect. So again, we found another combination that it works. So it's 3 combinations so far that it worked, and two combinations that nothing worked. So I'm gonna try the last combination. So I'm gonna turn on the solo, take out the motor, I go to the motion terminal again. So let's see, probably the motor will turn in counterclockwise direction, which is showing that the wiring is not correct because only one of the combinations will work. And yes, as expected, the motor is turning counterclockwise during Hall sensor calibration. This is the first indication that we can discard the wiring like now. So we have tried all the 6 wirings. We found 3 wirings that they were working for the motor and for the Hall sensors in this particular motor. Some types of motors, maybe you find only 2 combinations or even 1 combination in some special types of brushless motors, but for sure at least 1 combination of the motor's wiring will work. Thank you so much for watching this video. Please subscribe to our channel and we will keep you updated for new videos. Thank you so much.